This lectures cover the data cleaning and pre-processing. So we know in a real world or in a real world scenario, and data is often raw and messy or noisy. So before analyzing or before analysis or modeling, data must be cleaned and pre-processing. So these lectures, we are going to cover the concept of how we can, again, handle missing values, outlines, noisy or inconsistent data. For example, in data mining tasks, we always say we use somewhere between 60 to 80% of the time preparing our data. That's the data preparation phase, both transforming the data and removing any noisy error, etc. So here we can say, what is the definition of data cleaning? So we can say data cleaning and also pre-processing is the process of detecting and also removing or correcting and removing corrupt, inaccurate, incomplete, or irrelevant parts of the data. So again, data processing is the process of preparing raw data for analysis. As we said earlier, the real world data is often incomplete and also noisy and inconsistent. So these steps hopefully transform the data into a high quality format, which will be suitable for building reliable models and also drawing accurate conclusion. And also data cleaning and pre-processing, very important, as we said, in data mining, data science, machine learning. So in this lecture again, as we said, we're going to learn the techniques for handling noisy, inconsistent, and also missing values. So normally the steps in pre-processing will be first data cleaning. Here we are going to face the missing values, possible outliers or duplicates. So we are going to remove duplicates, outliers, and also facing a missing value. That will be the data cleaning section. Then data integration, we are going to merge data from multiple sources, it can be even be different formats, etc. Then next is the data transformation, which in this section we are going to normalize. So normalization, scaling, and also encoding. So for example, for transformation, let's say we have a field and there's two values. One value is 10, one value is 1 million. Now, when we see that field, we can see that the difference between 10 and 1 million is very, very big. 10 will not have any effect. So we can transform this data or normalize the data, for example, using log base 10. So we can say log base 10 of 10 is 1. Log base 10 of million is 6. So now instead of using 10 and 1 million, again, we are going to use 1 and 6, which is far better. So that will be the data transformation. Then we're also going to talk about the data reduction. This is most of the time reducing the dimension. We understand the concept data science or data mining and dimension causality. So the goal here is to reduce the dimensionality. Possible also we can reduce redundancy. So data reduction. Now the goal of these steps is to ensure high quality data for accurate, again, analysis. Now, the importance of data cleaning, and the question will be, why is it important, data cleaning? As we mentioned, data mining, 60 to 80% of the time spent in data cleaning. In short, we can say garbage in, garbage out. So if we use a data with error or a noisy data, most likely the model we are going to build also will be a model with errors or noise So the phrase garbage in, garbage out perfectly summarize this, why data cleaning is important because the quality of our analysis is directly dependent on the quality of our data. This is often the most time-consuming, as we said, the most time-consuming part of data science project or even data mining projects. But it's also the most critical for ensuring the validity of our results. So doing data cleaning process, it will improve our accuracy. So first, the improve accuracy of a machine learning model. So in this case, I can say the models trained on clean data will surely perform better. Also to prevent biases, so missing and noisy values can mislead predictions. Also to ensure consistency, as we know, uniform format and unit make integration more easier. And lastly, we say to reduce errors. So here also outliers, for example, the outliers or even invalid records won't distort results. Yeah. So the next section is the common data issues. First, we have some few items: missing values, outliers, duplicate, inconsistent formatting, noisy data, which is errors or irrelevant informations. So incomplete data, sometimes we may have a missing values in a data set. This can happen due to various reasons like data entry errors or data collection problems or non-response in a surveys. Then a noisy data, what we mean by that is containing errors, so let's say random errors. So a noisy data normally contains random errors or variance or noise. And this could be due to, let's say, faulty measurement instruments or human error or data corruption. Now, inconsistent data will be contradictions in data. They are inconsistent. Contradiction data, often from different data source or improper data entry. Example here can include different format for the same value. Let's say we have New York. We spell it NY lowercase, or next time NY uppercase, or next time NUW space WNYORK, the full word. So there will be inconsistency here. Next, also we say about the missing values. Some fields are blank. So, and also outlines means some few data that will be extremely high or low values. So extremely values. For example, we can say an income is $100 million for an employee. That's impossible. Also, we mentioned duplicates. So with duplicates, we are repeating the same thing over. So to duplicate. So here we can say repeated rows due to merging or data entry errors. Next is handling missing values. First, we can go through the type of missing data. Let's say missing completely at random. Missing completely at random. This means the missingness is unrelated to any other variable. For example, a survey question was accidentally skipped for a random subset of people. So we may have some missing. Also missing at random. Here we say the missingness depends on other variables, but not the missing value itself. For example, here will be, let's say men might be less likely to answer a question by weight. But the reason is it related to their actual, let's say to their actual weight. Also, we have a missing not at random. This means the missingness is related to the value of the variable itself. For example, people with high salary might be less willing to disclose their income. So here in general, we can say the causes handling missing. Well, we already discussed what can be again the causes of missing values. As we said earlier, human error, system failure, incomplete survey, sensor error, etc. So one of the techniques we can use to handle missing value, we can see deletion. I think that's the quickest. Deletion means remove the rows, or if it's columns, remove rows or columns with missing values. This is useful when few missing values. For example, in data mining, we may have one conventional rule saying that if your missing value is less than 10% of the whole data set, you can just ignore it to remove them. But when there are too many, one option will be if the field is quantitative, that's a value, we can find the average value of the whole column and we use it. Or if there's any special default value, we use it. Now, if it's categorical, then we can find the mode of the whole column. So the values that is common among the records, we are going to use that. Or if there's a default value also, again, we can use default value. So deletion is an option. Another option here can be, let's say, simple imputation. Simple imputation means replacing a missing with a mean, media, or mode, as we mentioned earlier. So either we can ignore it, remove it, or use mean, media, mode. Then we also have advanced imputation. So simple imputation means we can use a missing, replace missing with a mean, media, mode. Then the advanced imputation is like predicting the missing value, for example, using regression or using any supervised learning algorithm, for example, KNN or any again. Then the next will be the domain knowledge, very important. So fill based on expert rule. Expert rule. This is where we can set it, an expert can set a default value if there's a missing value. So the choice depends on the data set size and also the missingness mechanism, as we said earlier. There are some few trade-offs here. For example, deletion may reduce the data set size, while imputation may introduce bias. Because here we are introducing new values to the system. So again, we have something we call the listwise. A listwise deletion means remove the entire row or case if it has at least one missing value. It's very simple to implement. The disadvantage is that it can lead to a significant loss of data, potentially introducing biases if the missing data is not MCAR. MCAR means it's not the missing completely at random, as we said earlier. So here we have an example of how to handle a missing value. So here using our example, identify missing value. So we use the built-in function is.na. This will identify any missing value, sum. Then removing missing value, we use the na.omit. Omit. Then impute with mean. So here you can say we have is.na dataset age. We are putting back, we find the mean of the dataset age. So our course normally focus on Python. So this is our Python example. So here we first of all import pandas and numpy as PD and NP. Then first, to identify missing values, we use the isKnown.sum. And dropping the missing value, we have the method for that, drop NA, df.drop NA. Then impute with mean, you can see we are, first of all, we use the fill NA. Here we are dealing with the age dot MA. Oh, MAN, that's the mean, impute with mean. So we replace with mean. And here we are dealing with the age. So the next will be the handling the outliers. So first outliers, as we said earlier, will be a very extremely low or high value. And also it will deviate from majority of the data. So majority of the data is between 40 to 80. Then we have a value -20 or +2000. And we can see that this extremely high or low. Now, what are the causes? Here we can see it can be measurement errors or an event that doesn't, or rarely event that doesn't happen often. Or it can be fraud or natural variability. And the reason why problematic, here we can say they skew average and affect models like regression and cross-storing, especially cross-storing is very prompt to, again, outline data. So the techniques we can use here will be the Z-score or IQR, which is the interquartile. So here, Z-score, we're going to find values beyond ±3 standard deviation, which will be outliers. And interquartile method, here we say the values outside. Interquartile formula is 1.5 times IQR from Q1 and also Q3 are outliers. Transformation here, we say we are going to apply basic ones. We use that as example, the log base 10 or square root to reduce the effect. Then the domain rules, we can define as settable ranges normally. So again, outliers are data points that are significantly different from other observation. They can be either extremely low or extremely high. And they can be genuine anomalies or errors also. Visualization also can help us. So the detection method, we can visualize our data and we can see where the extreme high and low values. So for example, using box plot or scatter plot, these are two excellent for visually identifying outlines. And we mentioned in statistics method, we can use the Z-score or the interquartile range also, IQR. Treatment method here, as we mentioned earlier, deletion, that's removing the outline. Only do this if, again, you have a strong evidence that it is a data entry error. And also depends on the size of the data and the percentage of data that consists of errors. We can also do the capping. Normally, capping involves setting a threshold, example 95 percentile, and replace all values above that threshold with the threshold values. This reduces the influence of the outline without, again, removing the data point entirely. We mentioned about transformation already. So apply a mathematical transformation like logarithm can, again, compress the scale of the data. Also reducing the impact of extreme values also. So this is an example for outline detection using R. So here we can see R gives us a function, a quota, data set age. Then second Q3 will be 0.75. Q1 is 0.25. Q2 is 0.50. Q2. Q2 is the same as media because when you are looking for Q1, Q2, Q3, you still need to put the data in order, then find the middle. So it's the same process as finding the median. Now, interquarters, we know from statistics or interquarter range, we know from statistics is always the difference between Q3 and Q1. Now we're going to filter out the outlines now, outliers. So here we say subset data set, where our data is. Our attribute is age, greater than Q1 minus 1.5 times IQR, and age less than QR plus 1.5 in this. So this will be our data that we need. We always say the outline data will be below Q1 minus 1.5 times IQR. And also the higher outline value will be Q3 plus 1.5 times IQR. If it's greater than this, then it's outline. Same concept we use in Python too. So we have 0.25, 0.75 for Q1, Q3. To find the interquartile range is Q3 minus Q1. Now we're going to filter out the outliers. And the rule said for Q1, it will be, that's the lowest part of the outline value. When it's extremely low, it will be Q1 minus 1.5 times interquartile range. And we are using N here, so both conditions must be true. Second, we don't want any value above the Q3. So Q3 plus 1.5 times IQR will give us the higher extreme. So next we talk about handling inconsistent and noisy data. So inconsistent data means, for example, date within written differently. For example, we have date written, let's say January, we say 1/2/2023, which is January, January 2nd, 2023. Or we may say 2nd January 2023, or 2023 2nd January. Again. So this will be inconsistent. Actual example we have here, instead of writing the whole word male and female, we write M/F in the same work. So there will be inconsistency, or let's say the same data set. Next, we need to remove the noisy. So noisy is random errors or irrelevant variations. The technique we can use first can be the standardization. We convert all the categories to uniform labels. Then, of course, the data transformation, reformat date, time, and unit. Also, we talk about binding. Binding here means group values into intervals. Then regression smoothing, fit and smooth trend lines. Then clustering based filtering. Now, next is the technique for cleaning noisy or inconsistent data. So one of the main goal here, as we said, so here, first of all, let's go through. We have example for R. This is cleaning the data. So first we standardize the categorical value to lower data center. Then we convert also for date, convert the date format. We use the date function and we show the format year, month, and day. So what we're trying to say, we want to make sure these dates, all the data in dates column, they should be the same format. Categorical also should be the same format. So here we have a practical implementation in R. So again, first of all, the key library files we use. For Python, for example, we may use pandas. NumPy will work very good. And we're going to have a lecture on that, hopefully. Yeah. So here for the R, you can see we have the ggplot2 for visualization. It's very important to visualize your data, especially using box plot. That can help us to see the outliers. We're also using the DPLYR for data manipulation filter. Then this is studying data. So here, first of all, we load the package. We make sure that the package is already, or the library file is already installed, and we load it using the library function. Here we create a sample data with missing values. So to delete rows with missing values, since we have NA, so what will happen, NA.omit, it will remove all the NA missing values. Then impute with a mean, and we find the mean. Now, this is Python now. In Python, we import the pandas and NumPy. We create a sample data frame. You can see we have some NaN. And then we, again, use the pd.dataframe data into df. So now we're going to use the df. So fill missing values with the mean. So we say fill NA, that's the function which you fill NA. Then we say the df, the a.mean, in place equal to, again, true. So then we can see we have the Q1, Q2 the same way we use the R. Then we find the interquartile range. Then we set our lower and upper bound. So any value below lower bound is outline. Above lower bound is also outline. But it's high value and low value. So that will be the conclusion for these lectures. So in these lectures, again, we discuss about the data cleaning. As we said, data cleaning is critical before analysis because, again, garbage in, garbage out. So we make sure we clean our data. Then the main techniques we can use, as we said, handling the missing data with deletion or imputation, detect and treat outliers with the statistics method, and also possible fix the inconsistency and remove the noise. So R and Python provided powerful libraries for data preprocessing, from cleaning the data to better insight, reliable models, and accurate, again, prediction. So that will be the end of this lectures. Again, if you have any question, feel free to send an email. Thank you.